Hi guys, so in today's video we will be actually going to talk about a bit of machine learning and a bit of neural networks and a bit of other concepts that might mesmerize you, that might be heard by you in a day-to-day life, and you might be thinking of it, how they work and what's the needs of it, and how they're actually used in real life scenarios. So we actually gonna talk a bit of machine learning scenarios. It's actually daily Fridays, and we're actually gonna shoot that. So let's just forget everything else. Just forget everything else what we know. So let's actually start from the ground to us. In machine learning, what's the need for machine learning, and why are we actually going to this field? Why are we actually hearing there, here, and there the artificial intelligence and the machine learning all around? So machine can actually do only hard-coded logic, right? Only say what is actually programmed and what is actually being told, and say it actually just follows what is that supply the conditions on the by the humans and the different stimuli. And yes, so that's how the machine works. But in the real scenario, it's a lot more complex. It's really hard, and it's actually really hard to work in all the scenario and actually adapt to different scenarios. And that's where the basic intelligence of machine learning actually comes into existence, right? To adapt to different scenario and to actually generate a different concept that it can actually adapt to different scenarios and can find the solution on itself. That's where the basic essence of machine learning and different scenarios, actually different algorithms, actually come to into existence. So talking about this whole AI and whole field, what we have in hand, we have actually statistical methods, then we have machine learning, then extend we have deep learning methods, and then now it's the age or arena of say explainable AI. More on that, and what, and we can expect a lot more than that. There's actually not the stoppage, and there this is just a limitless field until we just achieve 100% accuracy, or say a human-like intelligence from the machines. This is just a field to explore to the limitless and to the infinite levels that are actually possible beyond human limits. We have actually also have dreamed of a particular level where a machine would be able to even perform even better than a human, right? So statistical method actually work on graphs, right? In basic sense, they actually work on graphs, right? We actually use to plot graphs. We actually do some mathematical calculations on basic sense, and then we actually use to find inferences, and that's where the statistical methods are actually just limited kind of stuff, right? In basic sense, not exactly, but let's go further. Let's go a bit further. Like in the machine learning methods, we used to use different models based on our data set, whether it is linearly separable or not, whether we want a complex or simpler model. We used to use some machine learning models like say decision trees, or maybe say probabilistic model, and based on the dependency and different assumptions we have made on our data set on the basis of domain knowledge, right? So similarly, we use different like Bayesian belief and other all networks, like logistic regression. There are many. There are just many not to count on. There actually is what is actually, and then we have a subfield of machine learning, say deep learning, right? Whenever we have to actually work on the images, who says that we can't actually use machine learning methods on images? We can, but we won't get accuracy, right? Because we need something more complex, right? In the image, we actually don't know that what equation to apply on the particular image to actually get a particular class. For us, image is actually so easy because brains, a large portion of brain is actually developed to actually recognize objects and images, but it's actually really hard for a computer to do the same, right? So for the deep learning methods, we are actually doing the same, right? The feature creation, right? A neural networks in a sense a basic entity that is a complex machine which can actually just create the features, right? It can actually create the features on its own. For example, you might have heard for the logistical regression and also say linear regression, we have a simple equation, right? We used to actually just find the particular weights as a parameters which can actually get you to a particular decision when actually multiplied or say applied on the values of a new data set, right? And we actually used to get the result. But which features and which powers of the features and which feature interaction actually gives a particular result, these all actually need to be created dynamically, right, on the basis of your data set. And that's what exactly a neural network does. it actually creates the interaction and the features on the fly from the input images. And as the training goes on, different weights actually used to get set up, and accordingly the features are actually created. That's actually what a neural network will do for you. Later on, going further, the now ANN is also not very much good. We used to actually apply CNN also on the top of ANN, right? CNN is actually a convolution neural network which has the convolution layers on the top of the neural network, and that what does is actually it actually sees a particular image by different ways. It used to actually apply filters on a particular image, and right, and then it actually used to give the different forms of the same image to the neural network in front of it, and then it actually used to find or say train the dataset on the basis of it. For example, if you have actually only seen the edges from the image, then you will actually predict this particular class. And if you will actually find some specific region from a particular image, or say light from a particular image, then you will actually get this particular class, right? So in this way, a convolution neural network actually transform a particular image by the basis on the basis of filters. It actually detects different edges or say different features from the particular image, and give the neural network in front of it the different forms of the same feature, and instead actually trains it in a better way, right? The earlier the ANN was only just training on the raw input images. Now the CNN will actually create different forms of the same image and will train now all this work done, you have actually got some accuracy, really great accuracy, because of some really complex neural networks and complex CNNs. Also, an image data set and different data set. Why are not we deploying it? So the reason is that these are black boxes. As the complexity increases for a particular model, the complexity comes with the cost of say black box, right? You actually know that what it is, you just don't know why it is. That is, you will actually get to know that yes, it is a cat, but why the neural network has actually predicted it to be a cat and not dog? And that's actually the main question which actually arises, and that you might ask. This question might seem to be really simple in a daily dog cat scenario, right? Dog cat example, but for a scenario of say cancer classification, like if a model is actually given an image of a patient having some lesion, right, and if it actually predicts that it is cancer or not, it can be dangerous for the patient, right? In some scenario, maybe for the training data set, it might not contain those type of images. It might not contain an image of a patient who has actually black skin, right? So for the training test set also, it might not be able to actually predict well. And even for the severe case, if it actually predicts that he's not cancerous, then it might be the case that the patient might die. So there's actually a talk of life and death here. So we can't actually just deploy a machine learning model in these particular scenarios, right? A deep learning model without actually knowing the reason for why. And that's where the essence of explainable AI came into existence, right? We are actually trying to develop really large number of say ways or say methods that could actually explain the decision of the models. For the simpler models, they are by default inherently explainable, but for the models which are actually complex, we have actually got a lot of model agnostic techniques which are actually independent of the model, and other ones which are actually dependent on the model, right? So we can actually talk about them a lot in the next video. That was actually kind of a brief about the topics which we might explore in the further series. Thank you so much for watching, and this might have give you some intuitions behind the basics and the ground truth that are actually lying in today's video. Thank you so much for watching.